Hi guys, welcome back. This is day 2 of solving radical equations. Today we're going to focus on things called extraneous solutions. And so I have a few problems here to deal with, and you'll notice that they look a little bit more complicated, but they're really not any more complicated. The x to the 3/2 power tends to confuse people. Remember, really that's saying that I've got x cubed and then I'm going to square root it, right? That's the same thing as x to the 3/2 power. But these are easy to work with. You're going to find out that fractional exponents are much easier to deal with than a sign that looks like this, okay? So here's the thing. In the previous day, we learned that the first step in solving a radical equation is to get the thing with the radical exponent, or the radical sign by itself, right? So here we're going to focus on this fractional exponent. We're going to do the same thing. We need to get this x to the 3/2 by itself before we can proceed any farther. That means subtracting 3 from both sides in this example, okay? So if I subtract 3 from both sides of the equation, I would get x to the 3/2 power on the left, and I would get 8 on the right, right? So just subtracting 3. Pretty simple. Now, the problem is I know that to get rid of a square root, I square both sides. To get rid of a cube root, I cube both sides. But how do I get rid of a fractional power? The easiest thing to do is just to raise both sides to the same power, and you're going to take the fraction and you're going to flip it. Raise it to the 2/3 power, both sides. The reason I do that is because now on the left-hand side, I'm raising a power to a power. And when I raise a power to a power, I simply take the exponents and I multiply. So if I took 3/2 times 2/3, we notice that everything goes away and I'm left with x to the first. So flip the fraction and raise both sides of that power, and that gets rid of it completely on the left-hand side. Now I simply have 8 to the 2/3 power. So I'm going to take my calculator, I'm going to raise 8. Quantity 2/3, right? Notice the parentheses there, and the answer is 4. The answer is 4. All right, so let's make sure that that works. When I go through here, if I take 4 and raise it to the 3/2 power, and then I add 3, does that give me 11? That's the question. So if I take 4 and raise it to the 3/2 power, that gives me 8. And 8 plus 3 does indeed equal 11. So we get a happy face here. Everything works out. The answer is 4, right? Let's look at a different problem here. Okay, I have x minus 2 raised to the 3/4. Oh, you know what's nice about this? This one already has the fractional exponent by itself, right? The chunk is already by itself. There's nothing multiplied. There's nothing added or subtracted on this side. So I'm ready to go. All I have to do is raise both sides to the 4/3 power. Okay? Because when I do that, then these go away, and I'm left with just x minus 2 on the left-hand side. On the right-hand side, I do need my calculator to find out what 8 to the 4/3 power is, and it turns out that that is 16. So x minus 2 is equal to 16. That means I add 2 to both sides, and x must be 18. Let's go through and check it. If I took 18 minus 2, and I raise it to the 3/4 power, do I get 8? That's the question. That's the original equation, right? So 18 minus 2 is 16. Let's take 16 and raise it to the 3/4 power, and I do indeed get 8. 16 to the 3/4 power equals 8. We do get a happy face. Everything checks out. So we really haven't hit any extraneous solutions, right? So I guess I should really have called this section here dealing with fractional exponents like 3/2. And so that's what I'm going to name the video. I'm going to make one more video here in just a second. It's going to deal with radical signs on both sides, and then we really get into those extraneous solutions here in a second. Okay?